I'm going to demonstrate our simple Java program that showcases a meal plan for the day. Our program includes two meal types, the breakfast and the dinner. Let's start with the main class. This is where our program begins executing. In the main method, we create two objects, the breakfast and the dinner. Breakfast is an instance of Tolentino BF, which represents a breakfast meal, and we provide it with the main course, side dish, and drink. Similarly as the dinner object, it is an instance of sugi dinner, which represents a dinner meal. Then, punta naman po tayo sa Biliera class. We have an abstract class called Biliera MP. This class serves as a blueprint for our meals. It has two properties, the main course and the side dish. The constructor initializes these properties. It also has an abstract method, guess meal type, which will be implemented by subclasses to specify the type of meal. Then the display basic details method prints out the meal type, main course, and the side dish. If you wanna po, we also hear the interface meal display. This interface po requires any class that implements it to define the display meal details method, ensuring that all meal classes have a way to display their details. Then here at the Tolentino BF class, which extends Miliera MP, this class adds a new property, drink. For the breakfast meal, the get meal type method returns the string breakfast. Then the display meal details methods calls display basic details and adds the recommended drink to the output. Then the last is the sugi dinner class, which is similar to the Tolentino BF. It also has a drink property and implements the meal display interface here. Then it has own get meal type method returning dinner, and similar it has its own get meal method returning dinner and a similar display meal details method. So to wrap up, when we run this program, it will display the meal plan for the day. If we run this method, we show to wrap up, when we run this program, it will display so to wrap up, when we run this program, it will display the meal plan for the day, including the breakfast and dinner details. As you can see, the program clearly separates the details for breakfast and dinner with the help of classes and interface.
Conclusion. The program effectively demonstrates the use of abstraction through the implementation of an abstract class or the Miliera MP class and an interface meal display in Tolentino BF class. By separating shared logic and specific details across classes, The program achieves modularity, scalability, and consistency. The build plan system showcases how object-oriented programming principles can simplify complex systems by organizing shared and unique behaviors logically.
Abstraction. Abstract classes allow the creation of a template for shared properties and methods while requiring subclasses to define specific behaviors. Interface provides a way to enforce consistent functionalities across different classes. Based on the code, we use Abstract to define the Miliara MP class as a blueprint for meal types, allowing the Sugi dinner and Tolentino to provide specific implementation for meal details while sharing common properties like main course and side dish.
Ability is straightforward. Developers only need to create a new subclass that extends the abstract class and implements the interface. It refers to the ability of our program to easily accommodate new features or functionalities. In our case, if we want to add new meal types such as lunch, we can do so without modifying the existing code. All we need to do is to create a new subclass that extends the existing abstract class and implements the required interface. This makes our program more flexible and scalable, allowing us to enhance it with minimal effort. Ability share methods and attributes in the abstract class prevent code duplication, making the program more maintainable and efficient. It is about leveraging existing code to avoid duplications. In our program, we have shared methods and attributes in the abstract class that can be utilized by all subclasses. And this prevents us from rewriting the same code multiple times, which not only makes our program more efficient, but also easier to maintain. If we need to make changes, we can do it in one place, ensuring consistency across all meal types.
Key point number 5 and number 6, encapsulation. Each class handles its specific responsibilities, like breakfast-specific details in Tolentino PF class, promoting clean food organization. And through this activity, we made this activity to solve real-world problems like meal planning through using OOP, especially the abstraction principle.
That's all, thank you.